Okay, here's another example. Let's say we have 75 grams of aluminum that start at 150 degrees Celsius, and we put those 75 grams into a calorimeter, which is perfectly insulated, and that calorimeter has a certain amount of water. I don't know how many grams, but I know that it starts at 22 degrees Celsius. So it's very important that a calorimeter is insulated, because that means that whatever energy aluminum loses, water gains, and there is no difference in those two Qs. If the calorimeter is not insulated, then part of the energy from aluminum might escape, like into the air or something like this, and this might be the reason why some of you, or many of you, got the wrong material in your lab, because materials like metals, they really, well, pretty fairly fast they cool down, so you could have lost some of the energy to the air while you were transferring into the calorimeter. And then plus, if you didn't close the calorimeter, or in our case those were styrofoam cups, if you didn't close them really tightly, I should say, and then some of the energy was escaping. So it's very important that this problem says that the calorimeter is insulated, because in this case you can be sure that energy that is lost by the aluminum is gained by water. And we need to figure out the mass of water. So the only way we can do it, we need to figure out how much energy was lost by the aluminum. That way we will know how much water, or how much energy is gained by the water. So what do we know for the aluminum? We know its Cp, we know its initial temperature, and we know that thermal equilibrium is 25 degrees Celsius. That is when the aluminum and water reach the same temperature. It's warmer than water, which was 22, and it's colder than aluminum, which is 150. All right, so let's go. 0.899, that's our Cp for aluminum, 75 is our mass, and then our change in temperature is negative because we went from 150 to 25, so our final is 25, initial is 150. We end up with a change in temperature that is negative, which is normal because you are losing energy. It should be negative. And so our energy that is lost is negative 8430. And since our calorimeter is insulated, that number, but with a plus, it's going to be a positive number, will be Q gained by water. And then how do we figure out the mass of water? We know Cp for water is 4186. We know that the change in temperature was 3 degrees because we went from 22 to 25, so 25 minus 22 is 3. And so we're using Q equals Cp m delta T. To find m, we do Q over Cp and delta T. And that gives us 671 grams of water was in that calorimeter, which was a huge calorimeter when you think about it. But then 75 grams of aluminum is, nothing to sneeze at either. Well, that's it.